Here's an example problem again for looking at power. We have a motor that's applying torque to a shaft. It's a 1/10 horsepower motor and it spins at 80 revolutions per minute. The allowable shear stress on the shaft is 4 KSI. I need to find the smallest diameter of the shaft to the nearest 1/8 inch. My assumptions are that the material is continuous and cohesive, the weight of the shaft is negligible, and we're in static equilibrium. So the first thing is we need to find the torque. So let's take our power and change the information that we have into a torque. Torque is then equal to power over 2 pi f, because I'm given frequency rather than the angular velocity. My power is 1/10 horsepower, but we need to convert that into units that match everything else. So let's go 33,000 foot-pounds per minute to get that converted. Divide that by 2 pi, and then my frequency is given in 80 revolutions per minute. So now all of my units match up. So I get 6.56 foot-pounds for my torque. Alright, so if my allowable shear stress is given to me, I know that that is equal to the torque times the radius over J. So we can put in the information we know. 4 times 10 to the third pounds per inch squared is the allowable stress that's given. And I just found my torque is 6.56 foot-pounds. Let's convert that to inches, because we have inches over here and we have feet here. So 12 inches, multiply that. And we're going to multiply that by c, which is our radius, divided by pi over 2 times c to the fourth. Now we just need to solve for c, which is a little bit complex, but it's doable. So we have 4 times 10 to the third is equal to 50.15 over c cubed. If I put all these numbers together, divide by pi over 2, and I can cancel out one of these c's on the bottom, this is what I get. So c to the third is equal to 0.0125. So if I take the cube root of this side, take the cube root of both sides, I get that c is equal to 0.232. But I need to find that to the nearest eighth of an inch, because I'm going to have to pick a standard size to purchase my shaft. So, and I need to multiply it by 2. So the diameter that I want to use, 465 inches, if I multiply this by 2, so I would want to choose a 1/2 inch diameter shaft.